Next up, we're going to hear from one of the United Kingdom's leading research experts on telecoms and open networks. He's going to discuss what is needed to transition to intelligent networks, or the intelligent next generation of infrastructure. Please put your hands together for Professor Rahim Tafazolli, the Head of Innovation for the University of Surrey, one of Rakuten's leading partners. Thank you very much. Thank you. Cheers. Thank you.
Thank you, James. Thank you. This is probably one of the few workshops I've been to which has not been dominated too much by mobile telecom people, but it is balanced with the IT people, which is makes it interesting for me and learning process. But those who don't know us, let me just give you a quick overview of what we are trying to do at University of Surrey in 5 and 6G Innovation Center. We are the largest academic research team in Europe, more than 200 people, PhD, postdocs, academics working on all aspects of the connectivity, from the satellite to terrestrial to Wi-Fi to future internet. And the research and innovation we are doing is a combination of theoretical research and experimental research to demonstrate that actually the technique that we come up with actually works in a real environment. So we were the first. We work very closely with industry. I think some of you, our industry partners are here. I see BT, for example. Our mission is very simple. We tell the technical truth, what is art of possible. And then our industry partners will decide to take it to the next step or not to take it to the next step, or what to do with the standards. We were the first starting in the world, starting 5G Innovation Center. You'll probably be surprised that UK was the first country in the world to do that. And that was 2012. And we were first in UK to start what we call 6G Innovation Center. And that was recognized by Royal Academy of Engineering for our outstanding contribution to industry and working between industry and academia in 2021. And last year for outstanding contribution and educating, bringing the skills up in the UK, especially small, medium-sized enterprise, that ITP gave us that award. Anyway, enough of that, awards. So 2012, we started 5G, and 2020, we started what we call 6G. And that was during the pandemic time. So we talked with our industry partners more than 9 months. We said, what should come after 5G? Because 5G is such a powerful, strong technology and is evolving over the time. So the question we ask, whether we call it 6G, we call it future telecom, whatever we want to call it, what does the market need in 2030? So that's the question we ask ourselves. What should we do? We cannot stop doing innovation. We need to carry on. Whatever label we put on it, that's irrelevant. So our industry partners said these 3 things. That's what we need to do. We want a system, a network, I think some of that what we discussed, that's going to be environmentally friendly and contribute to environment sustainability. So that's what they said. We want to solve most of the societal problems. We didn't probably ask the question about coverage. One of them is coverage. Broadband is important. So, societal problem and challenges. And the last but not least, they said we want to make money as well. It's not charity, all right? So we need to be honest with ourselves. So we had to translate all of this into a number of technologies. And also we realized that economically and from the energy point of view, we cannot provide universal coverage using one technology. It doesn't matter if it's 5G, 4G, whatever it is. So it has to be a network of networks. What other things is important that we need to bring into telecom is sensing. At the moment, most of the sensing networks are different from the telecom networks. So we need to combine them together. And that will open up not only new capability, new functionality, but also new type of services. And what we called teleportation, which I will talk about later on. So in 2020, we came up with this triangle. We said that's what 2030 requires. Coverage, universal coverage. That's important. Sensing integrated with the communication. And we also said we need, if 5G brought about low latency, so in whatever the future comes, 6G and etc., we need time synchronization. And that's become more important when we talk about interactivity between cyber and physical world, whether it is robots or people or robots and people or whatever they want to do. And we use AI, we keep open mind, we use AI on the wireless, on the network side, on the service platform, wherever it is possible. At the same time, we try to improve the AI and ML technologies. In 2023, ITU-R came up with this shape, with the blue ones are what we refer to as IMT 2030 or 6G. As you can see, everything we discussed 3 years before that, it actually ITU suggested the same things. Something I have to say here is quite important. The green one is the extension of 5G. And some of them, it says 10 times more lower latency, 100 times more data rate or whatever, or mass connectivity. I personally don't believe in any of these things because I don't think there is any use case with a business case for 10 times lower latency than 5G can provide, for example. So what we need to do in future telecom, start with a use case which makes a business case and come up with the KPIs rather than putting KPIs up front and we're trying to meet those KPIs and then we say, I'm going to make money out of it. So I'm quite happy with our own strategy, which doesn't have any KPIs. We identify one use case and then we work at what KPIs require. Let me just say that what I've said a little bit differently. What we think, whether we call it 6G, IMT 2030 or future telecom, branding is not the issue. Is intelligent convergence and cooperation between space and terrestrial. Network of networks, fixed and mobile, IT and telecom convergence, sensing and communication, which brings about new services and new way of network management, intelligence and telecom, and physical and digital world convergence, which brings about new use cases with the new business cases. We are pushing this on this as big assumption that it is fundamental principle of open and disaggregated network function. The same principle as in Open RAN, but we want to extend the openness to the rest of the network. It is not only just to reduce the cost, but also bring new revenue. That's important. As well as a new type of services. So, in a summary, what we are trying to do is we believe the strong role of satellite to handheld. That's important. Broadband, handheld terminal. That's the area we are researching on. I think probably it is very close to Dean's interest. We are also trying to extend the coverage, indoor coverage, because 80%, some people say, of the traffic is coming from indoor. How do we do that cost effectively? We look at these reconfigurable intelligent surfaces to extend the coverage into blind spots. And this is a technology we pioneered in 2020 and demonstrated, and this is a glass version of that, so we can make the glass and windows smarter. Sensing, not only environment sensing, environment around the network, but also the environment or information about the person. We take it one step further. We say we want to transmit all the human senses. So far in telecommunication, we've been transmitting two of the human senses, hearing and seeing, audio and video. So why can't we transmit touch, taste, and smell as well? So that brings about the idea that we mentioned. I'm not going to go into details of that. We call it teleportation. And that requires time synchronization. Anyway, new ideas, new invention that based on why we want to do this, we came up, we believe that OFDM or 5G is very strong technology. It's very difficult to come up with a new waveform that substantially can replace OFDM. So we came up with a new idea. We call it IOFDM. And IOFDM is very much based on the 5G NR, but allows high-level modulation speed. Even 4096 QAM, it can be transmitted, irrespective of the nonlinearity power amplifiers. AI, we believe that we came up with a new idea that AI can estimate the channel and channel environment really well, and without explicitly transmitting too much information between the device and the network side. And this is, we call it AI, Universal Channel State Information Feedback, which we think that is highly possible to influence the standards. Reconfigure intelligent service, I've already mentioned. Another thing that we do fundamentally different, everybody talks about digital transmitter and digital receiver. And at the same time, we complain about too much power consumption. We are asking ourselves, why don't we go back to analog? Digital modulation, coding, and etc., but we implement it in analog. Then we don't need power-hungry analog to digital converters, and etc. And this is one of the future important research areas we are working on. I will explain about AI network automation, and we are trying to send the electronic touch thing in future. So we are fortunate. We have a testbed, which is a campus-wide. It's a 4G and 5G. We can test lots of things in a real environment. And it is connected to many places in UK, so other organizations, they can remotely access it and test their ideas. It's connected to India as well as to Singapore. So we collaborate like Open RAN with India and Singapore and European Space Agency. So we use the same facility to test the 5G and 5G enhancement for space, for terrestrial, for Open RAN, for new advanced concepts. So this shows Minister George Friedman when he went to India and set up a video link between UK and India that using our testbed that we developed ourselves, 5G core testbed. We tested the 5G standalone in 2021. We achieved 1 gigabits per second. So it is not only 5G non-standalone, but 5G standalone. So let me go back to something that we've been discussing in this workshop. IT, telecom, and AI. We said there's convergence between these. Okay, it all sounds good. I'm gonna highlight the challenges and the problems with the examples of the network slicing. virtualization is a good thing if we're learning from IT industry. It makes the hardware independent of the software. It's fast and cost-effective upgrade of the new functionality, new services, reduces the cost, blah, 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 etc. We all agree on that. But at the same time, it brings its own challenges that the telecom people haven't been familiar with, and they need to understand this. It affects the performance, virtualization. You lose performance. Uses more energy because software is not designed for the hardware. And we have a delay, and we have delayed jitter. Delayed jitter is more important than the actual size of the delay itself for many applications. And it opens us to security threats. So we have to be careful of all of this. So an example, NF scaler, network function scaler, is our own technique. We say, how can we dynamically do network function scaling for network slicing using AI? At the same time, address those problems. So I'm not going to go into details of this. The red one shows the performance based on the bare metal, not virtualized networks. The yellow one is deep reinforcement learning. And the blue one is KEDA, which is Kubernetes event-driven autoscaler, which is used by many cloud providers. So if you look at the throughput, bare metal, of course, we can achieve the throughput. But our technique, we can achieve with the AI, with the new algorithm that we have, we can achieve the same performance as the bare metal. Jitter, which is very important, I mentioned. Obviously, when you have a bare metal, jitter is deterministic. You know where the delay and low latency comes from. But other techniques, which is used in cloud infrastructure, using the AI or other techniques, there is a huge amount of jitter. So it affects the quality of service. So you have to be careful with that. Latency per user, obviously bare metal, and then our technique is very close to what we can guarantee to the user. CPUs, how can we use CPU? This is bare metal. It's not dynamic, so it uses a huge amount of CPUs. And this is our technique that uses least amount of CPUs. So what we do, we sometimes switch off some CPUs because it's dynamic. We can switch it off and switch it on. And this is the power consumption. And ours is substantially less than the bare metal. So when we talk about IT, my point is, when I talk about IP and telecom, there's many advantages, but at the same time, we have to be aware of the disadvantages or challenges, not disadvantages, the challenges that we haven't been aware of in telecom, and then we need to come up with a solution with. It's not just simply putting the two together and say we are going to be happy and we're going to have a best network and etc. Based on this concept, we have a national program. It's called TUDOR, which is funded by the UK government, and we call it three-dimension network. We're working with 7 other UK universities and 16 industry, UK, as well as global industry, and trying to come up with integration and convergence between space and terrestrial using the cloud native infrastructure and using AI where it makes sense. So in future, we have universal coverage, on top of that, we have a cloud infrastructure which provides the connectivity and intelligence between different segments, different rate access networks. We realize the world is changing in telecom. So even our graduates are not suitable for future. of industry or academia. So we needed to provide skills and training. With the new skills I mentioned, IT, telecom, security, AI, etc., etc. For this, UK Research and Innovation, EPSRC funding, we partner with Queen's Belfast Centre for Secure Information and Technologies. And we have a Centre for Doctoral Training. And it is based on future open secure networks. We call it FORT. And there are 21 companies are providing this support. Some of them, thanks to you, is here. There are, some of you supporters are here. And it starts in October. And we are trying to provide training for the graduates that are conscious of the industry problem and the way the industry is moving for the future telecom. To be able to know about cybersecurity, networking, as well as AI. Relevant to industry and society problems, being capable of solving complex problems as well, and be innovative in their solution, and provide high quality scholarly outputs. We said we have a funding to do at least 50 PhD students. We said to ourselves, this is not gonna satisfy the industry and academia demand. We're gonna probably hardly touching this scratch of this demand. So we said, and this is about 8-year program. So what's going to happen after 8 years? So we said we are going to capture this pipeline of skills from college students, from high school. They can come to our center or our centers in Northern Ireland or in Guildford, and etc. Start doing coding, learn AI, do these mini projects. Hopefully they get them interested in telecom, in AI. If they want in future, they can branch out. They can do AI, security, or network, whatever it is. Hopefully it'll end up training thousands of people by the time that we finish this one. So it's not a closed initiative. It's open to anybody to join from industry, from academia, that they can contribute towards these skills and training. Not only they will learn about technical things like space, terrestrial, comm, security, trustworthy AI, secure and trustworthy hardware. Hardware security is important. We don't talk about it very much. We normally talk about network security and the software security side, as well as the physical layer. So all of this based on this open networking idea that it. In addition to all the technical training, we also will train them how to innovate for the impact. Responsible research and innovation. To learn about the standardization, how many academics really know what is the importance of the standardization and IPR, for example. We all got to provide that sort of training, leadership and etc. So if I was a PhD student, you wanted to roll on PhD, I would sign to this one, to be honest. I didn't have that sort of opportunity at that time. Thanks very much. I hope I added some value to this discussion today.
Thank you very much, Professor Rahim Tafazolli. Much appreciated for giving your insight there into the academic perspective on what is next for telecom. Thank you very much.